Welcome to Cheenta Statistics and Data Science. Today we are going to solve this problem from IIT JAM MS 2020, problem number 34. The problem says that for real constants a and b, let M to be the matrix 1 by root 2, 1 by root 2, A, B, right? This particular matrix, this 2 cross 2 matrix, be an orthogonal matrix. Then which of the following statements is or are always true? So this is a multiple select question. That means more than one options may be correct. So there are four options. So let's see which one of them are correct or see. So M is this matrix, right? And M is orthogonal matrix. That means M transpose is actually M inverse, right? It's in the M. The inverse of this matrix is nothing but the transpose of this matrix, right? So M into M transpose is actually identity matrix, right? Just multiplying M both sides. So M into M transpose, this being M and this being M transpose, we get the identity matrix, right? Just multiplying the usual multi way. Just so this is 1, this is a plus b by root 2, again this is a plus b by root 2, and this is a square plus b square, and this is 1001. So just comparing the terms, corresponding terms, we get that a plus b by root 2 is 0 and a square plus b square is equals to 1. So from here we get easily that a plus b is 0, right? A plus b is 0. So obviously easily we can see that option A is actually correct. A plus b is 0. This one is correct, right? So let this be equation 1 and this be equation 2. So from here, squaring it, we get a plus b whole square equals to 0. That means a square plus b square plus 2ab equals to 0. Now a square plus b square is actually 1 here, right? So ultimately it's nothing but 1 plus 2ab equals to 0. That means ab is equals to minus half. So again, we get that. So ab equals to minus half and a plus b equals to 0. So ab equals to minus half and a plus b equals to 0. So option A and C are actually true. Let's see about option B and option D. So see, now a square plus b square is equals to 1, right? So b square is equals to 1 minus a square, and b equals to plus or minus root over 1 minus a square, right? This one, this particular one, right? Now, since see a square plus b square equals to 1 and b equals to minus a from here, b equals to minus a from this equation 1, we get a square is equals to half, right? Just putting minus a in place of b, we get a square equals to half. Therefore, a equals to plus or minus 1 by root 2. Now, since b equals to minus a, therefore, if a equals to 1 by root 2, then 1 minus a square is half, obviously, and b is equals to plus or minus root over 1 minus a square from here, right? We just found out this one from here, right? Plus or minus 1 minus root over 1 minus a square. Now, if b is simply root over of 1 minus a square, that means b is 1 by root 2, right? In that case, see, what I'm doing is a is plus or minus 1 by root 2, right? So if suppose I take that a is to be 1 plus 1 by 1 by root 2, that means the plus the positive 1 by root 2. If a is 1 by root 2, then b, if I take b to be simply root over of 1 minus a square, that means b is also 1 by root 2. And in that case, ab is equals to half, a contradiction, because you just found out that ab equals to minus half. So that means here, see, ab equals to minus half from equation 3. So if a equals to 1 by root 2, therefore b has to be minus root over of 1 minus a square, so that it is minus 1 by root 2, and so that the ab is minus half, right? Therefore, ab cannot be simply root over of 1 minus a square. Here, the option true to option B is not always true. This option not always true, because it depends on the value of a, right? It depends what value a takes. Similarly, last option, m square equals to I. Let us check m square. So m square is nothing but this m square, just m into m. So this is nothing but this matrix, this 2 cross 2 matrix. See, if a equals to 1 by root 2 and b equals to minus 1 by root 2, then all of these terms satisfy this every term. This thing becomes 1, this thing becomes 1, and these things, this term and this term becomes 0. So ultimately it becomes an identity matrix, right? Therefore, m square equals to I2 if a equals to 1 by root 2 and b equals to minus 1 by root 2. But if we take the other case, that means if a equals to minus 1 by root 2 and b equals to plus 1 by root 2, then we don't have m square equals to I2. That means identity matrix. We don't have that. Therefore, m square is not always equal to the identity matrix. Since we don't know, right? Because we don't formally know what value a takes. We just know that a plus b is 0, a plus b is 0, and ab is equals to minus half. But we don't know exactly what values they take, right? must have the opposite signs, we know that, but which one they take, we don't know that. So m square is not always I2, right? So therefore option D is also not always true. So basically option A and option C are the only true ones here. Okay. So yeah, it was a very easy problem. The only thing we needed to check was the case analysis, just to be sure that, because A and B are not exactly, we don't know exactly what values A and B take respectively, right? We do know they satisfy this condition, A plus B is equals to 0 and AB equals to minus half, but we don't know exact the values of A and B. So that's why it creates problem for option B and option D. So ultimately option A and option C are the correct options for this question. So yeah, there you have it, the solution to this problem. So do like, share, and subscribe to the channel for more exciting problems. See you till next time.